Howdy everybody in YouTube land. What we have in front of us today is a Powerbook Duo 2300 series, but also upgraded to 10. Now, this one is not in terrible shape. It's got your, standard molten rubber and all that fun crap. This is flaking apart and melting as expected. So that's just going to be how these things are going to get with age, so they're going to have to be cloned. Otherwise, besides that, it's actually in relatively decent shape. It came with the charger and a whole bunch of docks, which we'll go through here in a minute. But the downside is to this thing is that. Now, I don't know, since this is a passive matrix display, I don't know if I can actually fix this. That's to be determined. So I think what I'm going to have to do is take that panel apart and try some film and see what happens. I'm not really expecting much, but that'll dictate whether I continue fixing this or not. But beforehand, you know what? Let's just power this thing up and then just see what happens, because what is there to lose? Wow, that's bad. The hard drive is making some not so good noises. Holy crap. This Powerbook Duo 2300 210 hybrid is actually trying to run. It's trying. It's still stuck on this screen though. Oh wow, we're actually getting to a startup bar. I didn't even get that far before. Okay, yeah, this thing's interesting. It's running Mac OS 8.1, which you can just barely see in there because of the vinegar syndrome. But it's got 16 megabytes of RAM, so it is actually trying to work. I don't know what size hard drive this thing has in here. See, it is a... Yeah, I can't read that. Let's see if I can play with the contrast control and see it better. Yeah, no, probably not. 310 meg. Looks like it was set up on 1998. Let's look at the help volume. Or no, there's two volumes. There's main. If I get info on that one. Yeah, this is, let's see, 1.5 gig. Yeah, this is most definitely an IDE hard drive. Yeah, 1998. So yeah, 1998. So someone put like a 2.1 gigabyte drive in here, and it sounds very IBM. Maybe. I'm just guessing. I could be completely wrong, but well, it's running. I don't know if there's much I can do about that display though. Alright, so now we know it basically runs, well, with some issues. I noticed when I unplug the power, it won't run off the battery. So, of course, the battery's dead. At least I thought it was. But here's what I find interesting. If I measure the battery terminals here, this battery is holding a charge. Now, I don't know if 13 volts is the correct charge for this battery, but it is holding a charge, but it will not run off of it. So, alright, I think what I want to do next is take this thing apart, see what we got going on. But more importantly, I want to get that panel apart, and I want to see if I can actually fix this vinegar syndrome, because I don't think this will work, because it appears to be a passive matrix display. And because it's passive matrix, I don't know if I can actually fix it. But I know when I peel this off, it's going to stink up the entire room really badly, because that's what these things do. So Yeah. Anyways, let's get this thing apart. I removed the top cover, and you can just see how bad vinegar syndrome is corrosive in general, because look at all of this goop that's just all over the magnesium frame. Goes, it's round, it's all around here, you can see it all there. It's just everywhere. You can even see deposits on this keyboard too. I got to clean up that magnesium frame, but that is terrible. That is really bad. So let's see what kind of hard drive we have in this thing. Not expecting much. There's like little bits of stuff just flaking off of it. It's just nasty. Yep, it's IBM and it's OEM. That's interesting. So it's original. It's bad though, but yeah, I mean, look at this. I don't know what that is. Finally got the upper display assembly apart, which is what I really wanted to do. In order to do that, you got to tear the thing all the way apart. But this has the same problem that the Powerbook 100 series do. The standoffs are just shrinking and crumbling apart. There's pieces of the plastic over there. I can try to fix that, but I'm only delaying the inevitable. What I try to do with these is I'll grab a bit of this Plastistruct stuff, soak it in there to get it molten, to try to form it back up, wait for it to dry. Then I'll heat the standoff and just kind of get it in there even more. And then that should hold it, but I don't know for how long. But anyways, I need to get the panel itself out so I can actually work with the vinegar syndrome to see if I can even restore this thing. But it looks like there's the part number. So we have that at least. I like how similar this panel is to the Powerbook 100. So I removed the shield. I'm getting ready to take the screws out, but same type of capacitors with the same corrosion. And also, the backlight itself is removable. But wow, that one's bad. So I have to do both sides. Oof. Okay. The vinegar smell is strong on this one. Alright, so I got to figure out how to peel all that off. If I can. I don't know how far I want to go with this thing, because, yeah, it's not really worth much. In order to get this thing so thin, I see what they did here. They actually built the display into the frame. That's why there's a sticker here. So this is one display that's designed into this frame. And that's how they got this thing so thin at the time. It's actually kind of impressive, to be honest. But anyways, I question my own sanity and why I do this to myself sometimes. But yet here we are. Alright, so when removing the film, it comes apart in two layers, especially with these passive displays. You have the actual polarizing layer on the top, and then just below that, which is this layer here, which is all cracked and destroyed, this is the 45-degree circularly polarized retardation layer. This is what increases the contrast and makes passive displays look kind of blue. Without it, because I peeled a section off, you get more of a pink color, a purple pink, because there's another circular polarizer on the bottom. Now if I take that, you'll just get like standard passive, but it won't you won't have the contrast. But there's not a whole lot you can do because that film really isn't made anymore. So I'm trying a new technique here to remove all of this stuff, and that is this right here. Rapid remover, only in 60 seconds. So we're giving that a shot, and we're going to see how well that actually works. I think I can see it bubbling up. It's actually working quite well. I just got to be careful with it because I don't want it attacking the ribbon cables. Yeah, it's coming off the display, actually. So I'm going to work at this, because if I can leave this retarder layer on and this retarder layer is not damaged, then that would be ideal. Because then I can use standard film without removing the retardation layer. So that's what we're going to do. We're going to keep working at it like that. If that don't work, well, we have the scraper. This stuff really smells like that orange goof off, and it might just be its own little mixture of that, but The reason why these things fail is it's not the polarizing film that goes bad, it's the adhesive which damages the polarizing film. This stuff right here that I'm peeling off, this is just, this adhesive is very optically clear, and it's known as polyvinyl acetate, or PVA. This is the stuff that degrades, breaks down, and causes all of this. It's inevitable. It'll happen with every display that uses PVA. And this is the same stuff, the exact same stuff you see in like 1960s roundy color televisions with cataracts. It's the same exact stuff. That's what this is. Fortunately, we do not have a choice but to actually peel up this 45-degree retardation layer, because this cracking and spider webbing is actually that film from the adhesive below it. So we're going to have to use the knife, and we're going to have to get that up. We don't have a choice. Lordy, PVA is so evil. Now, only the edges were good of the film. The rest of it was all crumbling and falling apart, so I had to scrape it. You got to use a very fresh razor blade, as in brand new, to do this. And then after you get it all scraped off as carefully as you can, you just a very, very, very slow process. You scrape it all off. Once you scrape it all off, then we can hit it with some of this adhesive remover and keep going at it until it's all gone. Just be careful not to get into these ribbons, because if you get these ribbons with the knife, yeah, you're done. So just be super careful. Just like that, the top side is squeaky clean. That's what you're going for. You just kind of have to let this stuff soak in. And then while it's on there, you use that to scrape it off, and then just go after it with a rag and just wipe it down, and you end up with all of this goop, you know. So cleared all that off, and that's all the old PVA material and circular polarizer material. It goes away, and we're good. So now we got to do that to the back side. And unfortunately, since I can't get FSTN film, there's really no way to make this thing look 100% like it did originally. It's just, that's just fact. This panel should be crystal clear. Crystal clear when you get it all off of there. It just looks like a pane of glass. Then we got to experiment with polarizers and see what we get and what it looks like. That's going to be the fun part. Alright, so now that I got all the polarizing film cleaned off, I've got this stuff you can buy from 3dlens.com. Now, this is why you have to have the retarding film, because notice how purple that is. And if you try to adjust the angle, you lose contrast. You know, so you've got to get the angle exactly right. That's not the right angle. That is. So that's the right angle right there. So unfortunately, I can make it darker. More like that. But yeah, this hard drive is done. But yeah, that purple is caused by the fact that this is not the right film. Unfortunately. This is why you need that retardation layer. Because it's so pink. And no matter, well, this is a slightly pink film, but no matter how you adjust it, you can't ever get it right. The camera makes it look better than what it really is. It's just, yeah, so if I take another polarizer and add it with it, I can kind of like get it somewhat better, but yeah, it's, anyways. I've been playing around with this thing a little bit, and it's not great, but it's not terrible. So I have a pinkish polarizing film that 3D Lens sells, which makes it look a little bit pink, purple. But if I use the actual standard film, it'll look orange. And that's the problem with this stuff. So, I mean, it's not terrible, but it's not great. I mean, granted, it's a passive matrix display. This is just how passive matrix displays look, right? The camera's compensating for it a little bit, but at least, I mean, the thing is, though, it's usable. That's the important thing. You can actually use it. Now, what I've come to find out is if I keep this straight, it's a little bit light, but if I turn it just a tiny bit, it'll improve the contrast just a hair. So really, its ideal spot is at an angle with the pink stuff, you know, perfectly straight. So being at an angle is where it needs to be. But other than that, let's see what this thing is actually running, because I am curious. But at least I can actually use the panel now. It's better than what it was before. Yep, 100 megahertz 603E with 16 megabytes of RAM. Not bad. Alright, so moving right along. Well, at least we have the film relatively squared away. Yeah, that's why it looks purple, but I'd rather have that than orange. But I think this does have some type of circular polarization to it, but I'm not sure. I don't know. But the other elephant in the room is this right here. So all of those are going to have to be replaced because look at that. I mean, you can even see it right there. Jeez, it's bad. Well, luckily that's fairly easy to do, but I definitely want to go take a look on 3dlens.com and see if they have any type of polarization film that's circularly polarized. I'm not sure on that one. It works better with this film than it does with the other film. So I find that interesting. Alright, so on the Powerbook Duo, I decided to switch to an active matrix panel that had really bad tunnel vision that I parted out probably over 12, 13 years ago. It's been sitting in my junk stash ever since because I converted that machine over to color. Now, this one, I decided to bake it, and I baked it so hard that I actually ruined the polarizing film. But I don't care because this is a TFT display, so the stuff you can buy will work on this. So I'm not worried about that. What I wanted to do is, since I baked this thing at such a high temperature, I was up close to 225, 235 degrees for several hours. I want to see how well it took care of the tunnel vision, even if it's destroyed the polarizing film. Other thing I wanted to point out too is there's two plugs here. So this plug here is for the passive matrix displays. This plug here is for the active matrix displays. And this is one of those Poseidon branded active matrix displays. It's been on for a little bit, and while it's far better than what it was, it still has its issues. You can see right here. So the tunnel vision is still there, and you can't ever get it away 100%. I don't think that's possible, but you can improve it drastically. And I think I've done that here. So I'm going to let this run for a while, and if this doesn't progress, and remember, when I baked this thing probably like 6 years ago, 7 years ago, I think. Something like that. And it just sat around and never got to testing it. So I'm just going to let it run. And if it doesn't progress any worse than what it already is, I'll probably end up just using this display instead of the passive matrix display, because the thing is I can't get film for that display and it doesn't look right. Now, I'm currently waiting on some sample FSTN film pieces that I want to try and see what it does, but I'm not holding high hopes, I'll just say that. Now that it's been on for a while, yeah, it's bad. I mean, you can see it all the way around. Now, it's not as bad as I remember it being, but it's still really bad. So, yeah, that's not usable. So I have two options. I either use the passive matrix display with the wrong colors because I don't have the right film. It's not great, but at least I can see the whole image. Or I can use this passive matrix display, or active matrix display, but with tunnel vision. So it's like a trade-off here. What do I do? I really don't know. But actually, before I even make a decision, I kind of want to wait for the right film to come in, which has the sample film, like a 100 by 100 little sheet that I bought from 3D Lens. I got a couple different ones, left affinity and right affinity circularly polarized film, because I want to see what that does with the passive display. I don't know. There is also actual FSTN film on AliExpress, but it's like 60 bucks shipped to get it here for a small sheet. And you need two, because you need one on the back side and you need one on the front side. That gets expensive. They also sell transflective and reflective FSTN sheets as well. So that's neat to know. Anyway, so yeah, this is what we got to deal with. Not good. Now this film is shot anyway, and I kind of wonder if it's the film causing this, because the funny thing I've noticed is on vinegar displays that get really bad, it always has the same type of tunneling effect, almost identical. That makes me wonder if it's a property of the polarizing film and it's gone bad. So what I'm going to do, this is junk anyways, you can see the waves in it from where I baked it in the oven. I'm just going to peel a piece of this film up and just cut it off, because it's got to be replaced anyways before I can even use this display. So I want to peel a piece of this off, and I'm going to take some of my actual film and just look through it and see if it has the same problem, because I am curious. But I don't know if it's the bottom film or if it's the top film causing it, or if it's the film at all. I really don't know. But that's not good. All right, I took that little corner off, and it's definitely not the film, because you can see the tunneling still. God, that hard drive. Garbage. Yeah, it's definitely not the film, but it for sure is the panel itself, which I had a feeling it was, but you don't really know until you try, right? Anyways, but yeah, the panel is bad. Panel is bad. All right, but hey, looks cool. It's just very tunneled. You can actually see how bad the panel is, because the icons are burned into the panel from sitting on the desktop for a little while. And that's actually not burning. That's just, there's something wrong with the liquid crystal and it's retaining its charge. It's not supposed to do that. So yeah, this panel unfortunately is shot. But that's Hoseidon for you. Fast forward a little bit of time, and I bought a couple of these circular polarizers. I got these from 3D Lens as well, and there's one that's left and one that's right. They're different angles, I guess. Not sure what that means, circular polarized, but I just went ahead and bought a couple of small samples because I want to try these out along with the standard polarizers and see if that fixed my issue on the passive display. But there's something else I noticed, and someone else pointed this out in an earlier video of mine. You see this tape that they use? Well, if I look at this tape, let's see, I gotta flip it around, hang on. If I look at the tape, look what the tape does. It affects the properties of this. Someone was telling me they were using this cellulose-based tape on one of these passive displays and then putting a standard polarizer on top, and it fixed the issue. So some of these tapes might actually be made with a similar property that the retardation layer adds. I don't know. That's interesting to know, though. I tried a piece of packing tape and it doesn't work. So I think there's only specific versions of this tape that does. So imagine trying to find that specific tape and then find one with a sheet wide enough where you could lay down here. Anyways, I'm going to try the right leaning one first, and then the left leaning one, and then both right and left. We'll see how that works. Along with the standard polarizer, we'll see what happens. Doesn't hurt to try. I'm not really getting anywhere, so I've got the right angle one on the back, and then I got a standard polarizer behind that. Then I have this polarizer. But if I just use the two polarizing films without the one in the middle, you can see what it does. It's kind of, you can kind of get it, but not really. So that's L, this is L. Let's take a look at the right one here. This is right. You kind of get it, but not really. It's very green and pink, and it ain't right. So no, that's not going to work, unfortunately. I'll add another polarizer on top, but yeah, this is not going to work. I could try the tape method. Matter of fact, I stuck a piece right there. I'll stick another one on the other side, and we'll see what we get with that. Oh, it definitely has an effect, but not quite the effect I'm looking for. I mean, I can kind of get it, but not really. It's definitely, I mean, I don't know how to... I could take another piece and put it next to it on the top side, because this one's on the bottom side, this one's on the top side. They're sandwiched together. Now I need one just purely on the top side. I mean, it makes a difference, but not like I need it to. And then the circularly polarized film doesn't really do much. There's no change. Using them together only makes it worse and darker. So my idea did not work. I need a special film for this. Well, I mean, there's something to be said about this. We're getting a little closer, because the only problem is it gets it really dark. But I'm wondering if I can screw with the contrast and actually make that better. Yeah, a little bit, but not really. In the camera it looks orange, but to real life that actually looks gray now. But it screws with the viewing angle, see? So there is some merit to this tape method, but it's not going to ultimately solve my problem. But it's better than what we had before, honestly, because this is what we have before. Nice and orange. That's it. That's all we had before. But yet, that makes a difference. Really, really does. Alright, so since I can't get the right film for that black and white passive display without it looking really bad, I'm going to take a different approach here. I still have this vinegar display from a previous 2300C repair. So, I want to see if this display is any good, and if it is, I would rather just redo this one instead. Now, I don't know where the cable is. I got two different ones of these cables, but I don't know if they're cross compatible. I kind of lost track of all the cables. So I want to see if this display is any good. I don't even know if I have the right inverter. I suppose we're going to find out, aren't we? I don't know. Well, it is. This panel is good, besides the vinegar cinder, but I'm not worried about that. That's a weird spot. I need to make sure the backlight didn't get damaged, but although the backlight does kind of have that yellow halo around it, but the screen does work. So it is worth putting the time and effort into devinegaring that panel, which is what I'm going to do. This will be a far easier task to do than trying to find the right film for the other panel, because, well, we got to change it anyways. Anyway, so that is the avenue we are going to go in. That's what I think anyways. little bar down the side is just this backlight material. It actually stuck to the bottom of this film. So what we're going to do is we have to be super, super, and I mean super careful when we remove this film. Not only to prevent yourself from cracking the LCD, but also, especially when using sharp objects to peel the film, if you're not careful, you'll run right off and you'll cut these cough ribbons. And if you do that, it's done. Unless you have a replacement panel and an ACF hot bar press machine, you're screwed. So we got to be super careful with that. Ugh, God, it's nasty. This is the stuff that really tends to go vinegar. Ugh. Ooh, the smell right now. It's like, I'd rather sniff cap juice all day long than whatever the hell this is. I need a painter's mask. This shit is so strong. I tell you, this is the most disgusting and smelly job. Because it always comes apart in chunks. And again, you got to be careful around the landmines, otherwise known as these cough ribbons. So, yeah, it's terrible. Yeah, it's just coming apart in layers. It's not fun. Next thing you're going to want is one of these things. Now, you could use a straight edge and an X-Acto knife and do this if you're really good at it. Or you can use an X-Acto knife, which is what we're going to use. With this, you can do measurements, and I already have my measurements. So we're about 15 millimeters tall because I measured the film before I peeled it off. So I know I got 15 millimeters height. So I have it set for 15, and that's exactly what we got at the blade. And then we got to do 19.9 long, which is going to be somewhere around there. So we're going to do the rear film first. That way we can move around the front film until we get the right polarization angle, and then we'll mark and cut that one. Something kind of like that. So that should work out, I think. Ooh, I noticed something. There, the panel itself has got some polarization to it. Look at that. Oh, really now? Oh, I hope I didn't make a mistake. We're gonna find out. Because it's the same this way or this way. The only difference is if you go this way or this way with it, which doesn't make sense. So it's a TFT display, not a DSTN. That's the only reason why we can do this, because it's a TFT. But anyway, something like that. So I've spent almost 2 hours trying to get the bubbles out of this thing. They keep coming and coming and coming. And the problem is, this stuff, I'm trying this stuff for the first time because I was using like alcohol and it doesn't work that well. This stuff works amazingly well. The problem is the adhesive that's on this film absorbs this stuff. So it absolutely will not. I mean, you can rub all the bubbles out and still have bubbles left, but as soon as you get this film hot to try to release the bubbles, the whole thing bubbles up again, and then you get more fluid out. And it's because this adhesive is absorbing this stuff, and that's not a good thing. Right, so I've learned one thing. Can't use that, because look what happens. It literally ruins the adhesive. It's just not... Alright, well, whatever they use in this stuff is not compatible with whatever that adhesive is. That's trash now. Pushing too hard with too much heat. Destroyed the panel. That really, really, really sucks. Bad. And there's still bubbles in there. All right, well, that stuff is clearly a fail. That's not going to work. Good news is, though, that little spot went away that was over here. At this point, I mean, the screen, I can't find a replacement. So I think what I'm going to just do is go ahead and just do the top side film on this and then heck with it. Put it back together. So for the top film, I went back to my trusty 91% alcohol, and that worked out so much better. I don't see any bubbles at all anywhere. I mean, there's a little bit of a drop here and here because it's just the thickness of the panel is ever so slight. But other than that, there's no imperfections in the panel whatsoever on the top. All of the bubbles are on the one on the bottom, but this is also the matte screen and not the gloss screen because I bought all three films. I bought matte, semi-gloss, and gloss. I'm doing the front with matte and doing the rear with gloss, how it was done originally. Question is, does it have to be that way? Well, I don't know, but I used alcohol here and I'm not having any problems with application. It happens a lot faster, so you have to be super quick with it. But the edges take much longer to seat, which is fine. It gives you the ability to work out bubbles that are in there. So just, it works. That works so much better. Hopefully I didn't get any dirt trapped in there. Because that's what happened to the Toshiba T1, what was it, the T1100 I worked on? That had to do this too. Dirt got trapped in there. So, and I remember I tried to peel it up to get the dirt out, which ruined the film. So, anyways, so the only thing left to do now is this ribbon cable here. So from bending this around, working with this display, pushing on it and squeegeeing it for 3 hours, well, not that long, like almost 2 hours, I've been flexing the ribbon like this. I broke a connection in here. Now, if I push on this with a little bit of pressure, I can get it to come back. It'll be fine because the break is like right here. So what I'm going to do is I'm just going to put a little bit of a foam shim in there and then just leave it alone and not mess with it. Besides a few little spots on the edges outside of the pixel area, the front came out far, far, far better than the rear. Yeah, that rear film isn't going to work with that applicator fluid. Alcohol works great. Whatever the other stuff is, doesn't work for this application. And it's probably because this particular film, because I've bought a couple different films from a couple different people, this particular film has an adhesive on it that's just not compatible with that applicator fluid. But alcohol works great for this stuff. Amazingly well, besides the edges here. And I think the reason why the edges look like that is because there's probably still microscopic debris from the original film. You can actually kind of see it a little bit here. Left over, and it's raised it up a hair. But you know what? It's better than what I had before. It was unusable before. Now that right there is what I'm talking about. Look at that. Much better. No, I mean, if there's bubbles in there, you can kind of see stripes and stuff, but you know, it's usable compared to what I had before when it was just like a complete disaster zone. The thing looks new. So you know what? I can live with that. Now I can finally wrap this project up and put it back together. Before I can do that, I need to create a brace for that right there. I got my finger holding it on the ribbon here to try to prevent that from, we'll figure that out. Someone has an interesting video on this computer and I have no idea what it is. I don't think I've ever seen that before. Also, there's another video on here. It says trailer, something another. This video here, I'm curious what that's encoded in because that thing is playing really well on this hardware. And yeah, that over here is that bad ribbon cable causing problems. But that's actually pretty impressive for this hardware. So I am kind of curious what that's encoded in. Alright, so the one thing I've noticed with this particular display, like I said, we have that band in there now because we have the damaged ribbon. It is what it is. Not much I can do about that. However, one thing I noticed is if I lick and use my wet finger, you know, the old-fashioned wet finger trick, and I can touch that ribbon cable and get the connections wet, that stripe will go away. And it will stay gone until, of course, it dries out and it doesn't work anymore, right? It comes right, the fault comes right back. What is actually going on there? Well, the thing is, your finger and saliva and all that stuff contains sugars and salts and everything else. So your finger essentially becomes a resistor. So what you're doing is you're creating a resistance in where the fracture is, where the break is. You're creating a resistor, but you're also creating resistors across all the electrical connections too, but the resistance is not high enough for it to drop the impedance low enough to actually cause any problems with the driver circuitry. So it's like having a termination resistors connected across there and in series and stuff like that. It's very similar to that. Yeah, you'll get crosstalk, and that will be a problem if there's a high impedance connection there. But there's generally not. So we don't have a problem there. So what can we actually do about that? And let me tell you, this is going to be a Hail Mary. I'll tell you that right now. And that is this stuff right here. This is a premium carbon conductive grease 8481. There's a few different versions of this. There's some that are silicone based, some that are not. They're synthetic grease, you know, things like that. And they've got different resistances per centimeter. Now, like I said, this is a Hail Mary, but this is essentially your wet finger, but it's a grease and it won't go away and dry out. So it's made out of the same stuff resistors are. This is carbon. So just like a carbon film, carbon copper resistor, stuff like that. I think this is like 200 and something ohms per centimeter. So it's fairly low, but not super low. There was another one that was like 63 or even lower than that, and I didn't want to go that low. So the hope with this is if you put a little dab of this in the cable, it'll create a low enough resistance if it gets in the crack to actually recreate the electrical connection, but still maintain a high enough resistance that you don't short the connections in between. Because like if you used a conductive ink pen, that's just the same as just jamming a screwdriver in there. So that's not going to do you any good, right? So that stuff there, I'm hoping will work. This has never been tried before. I randomly came up with this idea after hashing it out with a few other people on Discord, and then it's like, you know what? That's worth a shot. This stuff's not cheap either. But if this actually works, oh boy. I mean, there is a possibility that I can make this worse, way worse than what it is now. If I use this stuff, I can make it worse. But the thing is, it's already got a problem as it is. So honestly, I'm tempted of just dabbing a little bit of this stuff on a Q-tip and just touching where I think the break is, massaging it in there a little bit and see if it works. I mean, it's a toss-up. It's one of those situations. Do you leave well enough alone, or do you do this in the name of science? And here's kind of why I want to take the risk. Because on Yahoo Japan, I found an empty 2300 shell. Because the thing is, I'm missing, in order to use the color display, I need the color housing. Well, I have the front half of the housing, but not the rear half. So I figured I'm going to have to get another parts, 2300C to make this work. But one popped up on Japan recently. I say recently. I'll get to that in a minute. That was just an empty shell for the color 2300. It's like that couldn't have been even more perfect. So I put a bid on it. And the thing is, I couldn't bid on it with the buyee. I had to use Zen Market. So here comes the problem. When I chose the shipping through Zen Market, they shipped it, but when it got here at the States, they used OCS Worldwide as the shipping carrier, and I'm like, why is this taking so long? So I looked up the tracking number, and it's just been sitting and sitting and sitting, and it'll go to another warehouse, and it'll sit and sit and sit. So I googled OCS worldwide or OCM or whatever it is, and the reviews are terrible. It's like, well, gee, it's already been a month and I still haven't received it. At this point, I may not receive it, so this could all be in vain anyways. So what is there to lose? If I can't get that fixed and I can't get the rear cover because it was eaten by the OCS monsters, I'll just have to go back to the black and white one and just deal with the color shift purity issues. But anyways, I've rambled off enough. Let's try this stuff and see what happens. Yeah, I figured it was a Hail Mary. I gave it a shot, and all I did was just make my hand a mess. But no, that didn't work. I guess this stuff is just too thick, and it can't really get in the crack. So maybe I can thin it out a bit. I don't actually know, but it kind of sucks, unfortunately. And it just shut off on me because this hard drive is bad. But yeah, it's unfortunate. But I did give it a try. I tried to. If I put it on too thick and it was shorting everything out, but you can kind of see where I just barely got it in there. But it's not quite where it needs to be, unfortunately. Ah well. So here it is, the middle of January. Guess what? Finally arrived. So I got this off of Zen Market because, I mean, how often does this happen? Like, someone posted this on Zen Market like this, a shell. Because remember, I was missing the rear cover for the color version of the Powerbook Duo. So this popped up just like this, in this condition, missing all the pieces for like, I don't know, I think I paid $20 for it. I don't remember. That's mind blowing to me. So yeah, I have everything else. Just I'm missing this rear cover. So, but I have the trackball version of this. But now that I have the whole complete assembly, I might as well just use it. So, and it looks like this one had gone vinegar syndrome too, because you can see the corrosion from the acetic acid attacking the frame, just like the other one. But anyways, so now that I have the parts in, yeah, the LCD is going to have a stripe in the middle a little bit, but there's nothing really I can do about that. But at least I have the rest of it. Now this one's got broken standoffs and stuff. So the bottom cover is essentially useless. But I have the top one at least. So, and I have the rubber side pieces, which I was missing on the other one. So I have just enough parts between them all to get them to work. The problem is these particular machines are notorious for these standoffs back here breaking. Fortunately, Colin from This Does Not Compute has a 3D printed model of the standoff, so we're going to have to do that mod as well. Wow, so you can see where someone tried to glue it, but failed, so they parted it out. You can see the, like, epoxy or whatever there, so that's not going to work. This has a 96 date stamp on it, which concerns me because it makes me wonder if this is also the same brittle plastic that Apple had everywhere else in that era, because the earlier stuff wasn't like that, but the later ones, I suppose an easy way to figure that out is this right here. So if I cut this standoff off, oh yeah, that's brittle. It just literally crumbled. Yep. This is brittle plastic. So this machine was made with that bad mold, unlike all of the older ones. So yeah, this is extremely brittle plastic. I bet this is too. Look at that. Just anyways, no way that's gonna hold. We're gonna have to grind this down and glue the new one in. Don't have a choice with that, unfortunately. I don't know how close we're going to be, but hopefully we're close enough. And remember, these holes are smaller, so even if I'm off a tiny bit, I can take the brass stand off and just heat it up and move it ever so slightly in any direction. So I do have some window of opportunity to play with this thing. Wow, I see why this one was parted out now. Someone left the battery in it, and I bet it destroyed everything. This thing is rough. You can see the corrosion around the magnesium frame. So this magnesium frame is pretty much scrap. I got to get this plastic stuff off of it so I can take it apart and, you know, part it out to get the other one put together. So, but yeah, this bottom cover is trash too. We got a broken standoff here. We've got a broken standoff here. I think this one went there. Oh yeah, it's crumbling for sure. So this thing is toast. It sucks because this one has the PowerBook 2300 series logo on the bottom of it, while the other one does not. But I'm pretty sure this is that brittle plastic too. No, it's not cracking. So maybe not. Maybe not. But, oh wow, look at this. It just, that's definitely battery acid. So, alright, well, you are going to go into the scrap bin because you are clearly 1000% shot. But same thing with you once I get the cable and everything off of it, because I'm definitely saving the cable and the plasticky bits for the other one, because the other one, I think one of this is broke or something. I don't remember, but we should be able to piece one together. Screen won't be great, but it's better than nothing at all. Alright, before I start putting too much attention in the screen assembly, as we've been doing through this entire video, I need to get this thing completely apart, get this corroded out magnesium frame out of here, get some new caps in here, and get it back together with another hard drive, because remember, this hard drive is bad and it only works some of the time. I will honestly say, though, this has got to be some of the worst cases of corrosion I've ever seen. This magnesium frame is toast. So I'm going to strip it down, remove all the plasticky bits, and the trash it goes. Now that I have the board extracted and I have that powder puff of a magnesium frame out of my way, I noticed that these little covers are getting brittle. They're just literally cracking and snapping apart, which is not a good thing. And that's probably why I've got so many of these that are just missing. Because, I mean, look at this. It's just, yeah. Because all of my duos, I think out of all four of them, only one of them still has both of them intact. They're all missing. And it's because they're getting brittle. But they're designed to hug this screw here and ride around the screw when you swivel this foot. But, yeah, I think the only way we're going to get this to even remotely hold in anymore is to get some hot glue or something and just kind of tack it in there. Otherwise, it's just going to fall out. But anyways, moving right along, we got to get these caps out of here and get them replaced. So there are four 100 microfarads at 35 volt. There's a 47 at 35, 100 at 25, and two 33s at 25. Fairly straightforward. So let's pull all that out and get them replaced. This board was made in 1995, so it's relatively newer than the older stuff Apple did, but I'm pulling these caps out and they're only just starting to leak, because there's a little bit of evidence on the spacer, but there's nothing on the PCB itself. Maybe a little around this pin. It's hard to say, but I just got to those in the nick of time. That was also the only one that was leaking. None of the rest were, so I got incredibly lucky. All the fresh capacitors have been reinstalled, or well, install them for the first time anyways, I noticed that these guys are a little bit smaller than they used to be in the old days. Because the originals were so much larger, but yet this 4735 is almost the original size. Anyways, and it's possible because these are supposed to be have a higher ripple current than what I could get now, maybe, or just I don't know, just theorizing. So, okay, we are ready to reinstall this back into the case, but we need to reassemble the new frame with some of these original parts. The one gripe I have about these duos, I have a few, but one of them is that CPU heatsink. So there's a bit of a gap there, and there's a silicone pad, a sill pad, that sits between the two. The 2300C, the original, has the heat spreader that's part of this because they know that it's not going to touch this one very well. Well, this one's missing that, so I had to grab some thermal paste and this sill pad because the original did not have the sill pad here. So I had to grab the sill pad from the parts one, shove it up under there, and try to. I don't know. I don't like it, but it is what it is. That's the first gripe I have about it anyways. The second gripe is the keyboard. The keyboard's atrocious. And now they're starting to develop problems where the keys aren't registering, so I got to figure out a solution for that. I just don't know how we're going to do that. But anyways, we need to move on. The next thing to move on to is figuring out what we're going to use for a hard drive solution because the original one is no good. So I do have some 810 megabyte drives that are new old stock, but the original was a 2 gigabyte. So that's going to drastically cut down our storage space. But for a machine like this, it probably doesn't matter a whole lot. I just have to get something in there. So that's what we're going to go do, I think. New old stock. Because why not? Now, chances are, because this thing's been sitting for 30 years, I'm going to have to probably tap on this thing to get it to spin up, to loosen up the stuck heads and the stuck spindle motor. But hopefully she comes alive, and if she does, that's the one we're going to put in there. One thing I will say, though, now that I just realized this, the hard drive screws that held the original hard drive in were missing. And while it's been a few months since I worked on this machine, and I don't think that I took them out of there, which means the hard drive was already having issues. Someone took it out to mess with it, put it back in there, and said, heck with it. And that's probably what happened. So the drive was bad for a long time. So I had to go through my spare screws bin here to try to find something, all different lengths, shapes, and sizes to fit the thread pitch of this so I can put the rails back in here. This is assembled as about as far as I can go with it. I got to get the screen back together because I can't put this top cover on until I get the LCD ribbon cable in there, and I can't get the LCD ribbon cable in there until I get the screen together. So that's our next move. We got to get the screen reassembled. I went to put this top cover on just to get it out of my way, and it wouldn't fit. That's when I realized these metal frames are not the same. Because there's the original frame, and if you look, the replacement frame has got this little standoff thing in the way. That one does not. So that is not the same. I don't know how we're going to fix that. Yikes. You know the nice thing about magnesium? It's very brittle. So you could take a pair of pliers and just barely twerk on it and it'll snap right off, which is exactly what I did here. So hopefully now it'll clear the case. I have no idea what that was about, but it clears the case now. So that way it's going together without any ill effects, fortunately. Before we can put the screen together, though, I got to change out one capacitor on the inverter, which is this 10 microfarad at 50 volt. Why it's 50 volt, I have no idea. Ooh, there's another one here. There's a 2.2 at 50, which I think I have. I got to look in my stash to see if I even have a 10 at 50. And like I said, I don't know why that is, because this inverter doesn't see more than 25 volts. So a 10 at 35 makes sense. A 10 at 50, not as much. But regardless, we have to replace that. Those two are now taken care of. Now, finally, we can start reassembling the screen. Alright, so that's been reassembled as best as we can. We're missing the shield, but is what it is. So that's in there, and the only thing left to do now is to get the nutserts in there and get this thing reassembled. I mean, this is basically going to be a hack around parts unit anyways, because again, the screen has a stripe in it, but it's better than nothing, I suppose. Perhaps I should have got that rubber off before I put it together, but is what it is. We're just going to go ahead and get that rubber off now. But other than that, it's reassembled and the screws are back in place. And it's being held together by some miracle. Pixie dust. Alright, well, here goes nothing. So, let's grab a power cord, plug you in. We got a chime. Move the screen up. Do we have anything but a chime? Yes, we do. Besides this chime in the middle of the screen. But, hey, hard drive spun up. But we've got no OS, which is fine, because we don't have a way to start it. But that's okay. We're good. We're good. The machine is running. Being able to see something there instead of nothing at all is better than nothing at all, in my opinion. And also, the two screws that went here, long ones, were put in at some point. So I have another one of these bezels anyways. So yeah, it's fine. Now I gotta fire this thing up and get an OS installed on it so I can test everything out. And to do that, I need to get a dock connected into it. I tell you what, the Blue SCSI CD emulation is awesome. I love that. I mean, that's usable. You could tolerate that. Everything would work fine with that. Oh, good. So it's picking up the internal hard drive, so we can actually start formatting all of that. Oh, that's bad. That's not supposed to be contrast. Anyways, we'll fix that. The OS is installed and is working fine. That is gonna do it for this machine. It's pretty much back together. The keyboard works fine. The machine's running fine with the new old stock hard drive, of course. It's as good as it's gonna get. I mean, the LCD has some issues, but there's not much I can do about that. And you know what? It's color active matrix, and it's the 2300C, so I kind of want to leave that as the 2300C. So that is going to be it for this machine here. All of that crazy work just to get to this result. Anyways, more importantly, I'm not gonna give up on that black and white LCD just yet. I think there's enough parts left over between the remnants of the junk that I have kicking around that allows me to use to build another one of these with that display as a 68K, because I have some 68K boards that are dead, but between the two or three of those boards I have, I might be able to make one work, and I might be able to make one more of these machines, maybe, but I may not have enough. I know I'm not going to have any more of these, because these are basically non-existent, but I don't know. I might be able to make something out of that, but we'll see. Anyways, this machine seems to be working fine other than the LCD, and that's, I don't know what we got going on here. I don't know why it does that. It does that and it makes the screen washed out. It's a weird bug. Anyways, that's it for this one. So if you enjoyed this video, don't forget to hit the like and subscribe and all of that fun stuff. Please feel free to leave a comment if you have one. Until next time, guys, thank you for watching.